Kubernetes?
Kubernetes is the orchestra for the container to manage the container, expand, like workload management.
Okay. What about you, Manish?
Again,
I was saying that what do you think about Kubernetes?
okay, so what I have understanding of Kubernetes. Kubernetes is a tool which uh, orchestrate the containerized things. This is the understanding I have.
Okay, Nagi, what do you say?
Auto scaling. These features are provided by the Kubernetes on the on the containerized environment.
Okay,
It's
and what
similar
about
kind of
like,
Docker, but it's similar kind of Docker, but there will be some of the other features added, kind of like performance or scalable kind of things.
And it
Kubernetes.
provides the other thing like telemetry services or something. Yes.
okay. Okay, that's great. Now see, uh, let me give you some examples over here. Now, let's say you are working on Docker. Okay, this is your Docker host. Clear? On this Docker host, you have created a container. Okay, and that container is actually running Apache. Okay, very simple example. Clear? Now, and you have done a port forwarding over here, 80 port number, 80 port number. Okay, and you have done the mapping. Clear? That's it. Now, let's say at night 2 a.m. if this container will go down, okay, what you will do at that time? Let's say the container is running fine in the evening time, but in night at 2 a.m. okay, when you must be sleeping, okay, the container goes down.
Kausha, there is a
What are the
delay.
ways to avoid these type of situation?
Kausha, there is delay in record sharing. So I'm facing the issue myself, or other one is also facing.
Are you feeling any lag in my voice and the screen sharing? On my side, the speed is quite good. Ashish, Nagi,
Yes.
issue हो रहा है?
Yes, good. Yes, no issue from your side.
Okay, so Manish, maybe on your side the problem is. Okay, now. So tell me, Ashish, if at night 2 a.m. this container goes down, what will happen? Obviously, application will be down. Clear?
Yes,
Now,
production
what
time.
you can do to avoid these type of situation?
So we need to create the replica of the same container. So if anyone is down, so it's automatically scale up or automatically start up the new one replica on other node or say on same node.
Yeah. So see, obviously, if you are working on Docker, first thing you need to do the port binding again and again. If you want to run 15 containers of the Apache on same system, you cannot run it. Why? Because once the 80 port has been binded, you cannot bind that port with another container. Clear? That is the always problem. Clear? Now I cannot create multiple load balancers, network load balancers, okay, for each application. Clear now?
Yes.
The second problem is when this container will go down, obviously maybe you have like configured a alerting system. That alerting system will inform you on the mail, but obvious at night 2 a.m. you must be sleeping. Obviously, I do not have any way to make that container up. In the morning when I will check my website, I will know that on that system, on that Docker host, the container goes down. And I will go to that system, I will take SSH, and after that I will like again run the Docker run command. Okay, now this is the always problem in the Docker. Clear? Still, you can use some monitoring tools, but that monitoring tool will inform you that the container went down, but it will not automatically create it. Okay, you need to create it. Okay, and if you're not on that system, that's it. The application will be down, the website will be down. Okay, customers will not get any details while hitting your website page. Now, for that, in the Kubernetes, what we have, Kubernetes have a concept of controller. Okay, now what this controller does, this controller is actually managing the actual room temperature. What does it mean? Let's say you are telling your controller that I want 4 pods in my cluster of Apache web server. Now, what is a pod? Just understand that pod is a container right now. I will tell you everything about a pod, but for right now, just understand that the pod is only a container. Clear? So I want 4 pods in my cluster of Apache web server. Clear? Now, what this controller will do? Obviously, you have to decide your desired state. 4. If any of the time, if this container will go down or if this pod will go down, okay, your actual state would become 3, and automatically it will make your actual state equivalent to the desired state. It will automatically create one more pod, means it will always maintain the 4 pods in my cluster. Cluster is what? Group of nodes. This is only one node, node 1. There can be multiple nodes inside your cluster. On all the nodes, it will always maintain the 4 pods. Clear? So this feature is given by the Kubernetes. Now let's say the problem number 2 is on this Docker host, a very heavy traffic is coming. Let's say 1000 or 1 lakh requests per second are coming. And this Docker host is only having 32 GB of memory. Obviously, for 1 lakh requests per second, the 32 GB RAM would not be enough to handle the traffic. Clear? So what I want to do, I want to create one more container. I want to do a manual scaling. So if I'm running Docker, I will create one more Docker host. Clear? I will create one more container over here. Okay, which will be running Apache, and that system is what is having 32 GB of RAM, let's say. So as the load increases, I will add new worker nodes, and I will add like new containers on it, and I will like distribute the traffic. So, but you need to create it by yourself. Clear? But what exactly Kubernetes has? Kubernetes has a feature to scale your application. Okay, so manual scaling and automatic scaling. These both the features are actually given to you by Kubernetes. Okay, so this is the feature number 1. This is the feature number 2. And this is the feature number 3. Clear? Now, automatic scaling is actually done by Kubernetes, but for that you need to configure some extra tools like Prometheus. Prometheus is a metrics tool, means it actually gathers the real-time data about the CPU and memory of the nodes. Clear? So on the basis of CPU or on the basis of memory, you would do auto scaling, right? If the load is coming or load is very high, or the memory utilization and the CPU utilization is very high on this Docker host, automatically it will create a new container or new pod on the another worker node, and it will distribute the traffic. Clear? And manual scaling means you can run some commands to do or to increase the number of replicas, means the number of pods. Okay, now I am having 2, I want 6, I can give it. I want 10, I can give it. Clear? So these 2 features are not provided by Docker. These 2 features are provided by Kubernetes. Now let's say the second problem is, let's say you have almost $15 worker nodes, or let's say you have almost 6 worker nodes. Okay, and these 3 worker nodes are actually, okay, let me tell you a very easy example. Let's say these 6 worker nodes you are having. Okay, this is my node 1. Clear? This is my node 2, node 3, and so on. Clear? Now, on all the nodes, you will install Docker, obviously, if you are not using Kubernetes. Let's say on this node, you are having a SATA hard drive. Clear? On this node, you are having a SSD hard drive. On this node, you are having SATA. On this node, you are having SSD. On this node, you are having M2. On this node also, you are having M2. Okay. These all are the types of hard drives you have on different worker nodes. Clear? Now, if I tell you that I want to deploy two applications, one is I want to create a MySQL container and I want to create a Apache container. Now the requirement is MySQL container needs a very high speed or very high IO hard drive. So I want to create it on the hard drives which are having SSD. I want to create Apache containers on the nodes where the SATA hard drive is available. And I want to create the PHP application or PHP container where you have M2 hard drive. This is my requirement. Clear now? Once you are clear with the requirement, what you will do? You will find or you will go to each node if you are using Docker. And you will find that this node is having SATA, create a Apache container. This is having SSD, create a MySQL container. Now let's say you are having 50 worker nodes inside your cluster. How will you do it? You need to check each and every node to create some container. Okay. Now, so obviously it will take a very high time, but in the Kubernetes, what feature you have? You have the feature as scheduler. Now what scheduler does? Scheduler actually decides the best fit node for your application or for your app. Clear? Now how it decides the best fit app? That is the question. Now there are multiple algorithms. Okay. One algorithm is you can use node selector. What node selector is? Okay. Like the way you do filter in AWS, we use selector in the Kubernetes. So what I will do, I will apply the labels on each of the node. Like here I am applying a label as disk : SATA. Here I am applying the label as disk : SSD. Clear? Here I am applying the label as disk : SATA. Here I am applying the disk : SSD. Here disk : M2. And here disk : M2. These are what? These are labels. Okay. These are labels. Now in the node selector, what I will give? Let me just in the node selector, I will tell my scheduler that you always need to create MySQL pod on the worker nodes where the disk : SSD label has been applied. You need to create the Apache pod on the nodes where the label is applied as disk : SATA. And you need to create the PHP pod where the label value is disk : M2. Clear? This is how I can define my node selectors. Very easy. Clear? So automatically the scheduler, obviously with the help of selector, it will find that into my cluster, two nodes are having disk : SATA, schedule a pod on them of Apache. On SSD, it will schedule MySQL. On M2, it will schedule PHP. So it is taking decision with the help of disk. Now you can give the condition like this also. Let's say these three worker nodes are actually working in. You can apply the label according to the regions also. Region : US West -1. Okay. And these worker nodes are having the region as AP South 1. Clear? Now, I want to create an application. I want to create or I want to deploy a DB server. Okay. Or let's say I want to deploy a HA proxy on the system where the value of the region label is AP South 1. And the value of the disk is what? M2. Okay. Or SSD. Automatically the scheduler will find it that the label on this worker node is reason is colon AP South 1 and the this colon SSD. So automatically it will schedule the HA proxy container or HA proxy pod on this node. Clear? This is a combined label, okay, on all the worker nodes. This is also having reason colon this label. This is also having reason colon this label. Okay. I have just mentioned like this. Clear? So like this, with the help of scheduler, you have multiple type of algorithms and you can make your decisions. Guys, this point is clear? Hello.
Yes, you're audible.
Yes, yes. Is this clear to you?
Yes, Krishna.
Yes.
So first thing, controller, manual scaling, automatic scaling, scheduler. Number 5th, obvious high availability. High availability for what? Pod high availability and node high availability. Let's say if the container, okay, the Apache container is running on this worker node and at any time this worker node goes down, automatically it will create one more pod on another worker node because it needs to manage the 4 desired state. Clear? So you have the high availability of pod and you have the high availability of nodes also. Clear? So these are the Kubernetes features. Now let me give you present a PPT. So Kubernetes is an open source container orchestration engine for automatic deployment, scaling, management of containerized application and services. The open source project is hosted by the CNCF. It has a large and growing ecosystem. And this was actually open sourced in 2014 by Google. Okay. What are the advantages? High availability. Centralized management means you can maintain or you can manage all the worker nodes inside your cluster from a single node, which is called a master node. Scalability, manual and automatic. Project level isolation, we will talk about it. User level role-based access control means if someone is having access onto my cluster, what he can do, that I can define with the help of role-based access control. Okay. I hope you have heard about the IAM users and the policies and the rules. What we do in the AWS, let's say I want to give you a permission on my AWS account for the EC2 access. What I will do, I will create IAM user. I will attach a EC2 full access to that IAM user, which is a role or a policy. After that, I will share you the secret key and the access key. With the help of that secret key access key, you can log in on the user which I have created for you on my AWS account. And you have all the privileges to do anything with EC2. Clear? Because I have given or I have attached that policy or that role to user. Clear? So that type of role-based access control is used in Kubernetes also. Quota allocation, how much memory my pod can use, how much storage my pod can use. Okay, everything. Internal load balancing. Now you do not need to maintain the port mapping actually. Okay, for Kubernetes, you have an internal load balancer, which is called a service. Okay, it is a typo over here. Okay, kubeproxy is responsible to flow the traffic, but for load balancing, you have service. Clear? So internal load balancer has been given to you. You do not need to create your own load balancer outside the nodes. Clear? It is present inside the Kubernetes. Now, do you guys have any questions on this?
That's fine, Kaushal, I think.
Fine. Okay, now let's understand the architecture.
Sir, जो user authentication is inbuilt at utility in Kubernetes, or we need to install plugin or some software?
See, Kubernetes gives you two ways to do the authentication. One is you can create a config file for someone, okay, and you can give that config file to someone and who can access your cluster. Second is if you want your Kubernetes to use some OAuth protocol, then you can configure HAPassWD, LDAP, okay, Keystone, AD, all the things. Clear?
Can you means we can use the external AD authentication?
Yeah, but for that you need to configure the identity provider by yourself, and you need to connect it with Kubernetes. Okay, so for that you need to install packages and all the things. Clear?
Clear.
Yeah. Now let's understand the architecture. In Kubernetes, you have one worker node. First, you have a master node. This master node actually do or give you centralized management. Everything will be done on this master node. Clear? And from that master node, the instructions will be gone to the worker nodes. Okay? In case of you want to create some pods or anything. Now, here, let's say I have two worker nodes. Clear? This is my worker node 2. This is my worker node 1. Clear? Now, how this master gives instruction to these all the worker nodes. So there is an agent which is available on these worker nodes, which is called kubelet. Okay. And this master node also have a kubelet. Here. No. These are what? Kubelet is the agent. Okay, number one. Kubelet is the agent on nodes. Okay, which takes instructions and performs something. Clear? Obviously, if I want to do something, or if I want to create a pod on this worker node, whom I will contact? So I will contact kubelet. So this is what an agent, like you have in Jenkins, okay, or in any of the like master agent architecture, you always have an agent. Okay, Ansible is agentless, but otherwise all the tools are like with agent. Now on this master, you have four components. One is API server. Number two is controller. Number three is scheduler, or number four is etcd. Okay. Now, what does API server do? Let me write here. Number one, authentication. Who can access my cluster? Okay. And number two, authorization. Once the person has logged in into my cluster or into my master node, what he can do or what privileges the person is having. So these two things are managed by the API server. Okay. The second point is controller. Now in the controller, you have multiple type of controller. Replication controller, node controller, endpoint controller, service and token controller, like this. These two we will not discuss. Replication controller actually manages the desired state of your application, and node controller is actually responsible to give you the information if some node goes down. Okay. Now it will not automatically create a node for you. For that you need to configure something else. It will only give you the information. After that you have the scheduler. What scheduler do? Decides best fit node for your application. After that you have etcd. etcd, distributed database to store cluster configuration and cluster state in key value pairs. Okay. So these four components are there. Now, if some controller wants to communicate with scheduler, he will always go to API server, and after that, he will contact to scheduler. So everybody, if any of the resource over here wants to communicate with each other, they will all go via the API server. So API server is something like a middleman, okay, for whole cluster. Anybody wants to communicate with anyone, they always go with the API server. Controller wants to talk to scheduler, controller will give its information to API server will pass those information to scheduler, or API server will pass controller a token so that it can communicate with scheduler. Clear? So all the things are actually all the request and all the information actually goes through the API server. And only the API server is responsible to communicate with etcd. Scheduler cannot directly connect to this. Controller cannot directly connect to this. If scheduler wants to store something, controller wants to store something, they all will give information to API server, and API server will contact etcd. Okay. So these four major components are present on this, and they all are running in pod. Okay. All are running in a pod. Clear? Now, after that, the another component you have over here, which is kubectl. Okay. And what kubectl is? Kubectl manage traffic or network flow. Okay, forward the packets to different worker nodes. Okay, everything is defined by the kubectl. Okay. Now, after that, you have the Docker on all the systems, because that is what a container engine. Docker is what? Container engine. And in Kubernetes, future versions, Docker is going to replaced by CRI-O. Clear? CRI-O. OpenShift uses CRI-O, but Kubernetes in 1.23 or 1.22 version, it will actually remove Docker. It will be replaced by CRI-O. Clear? Which is also a container engine. OCI platforms are different. Now, we will discuss the differences between these two. So these are all the components. Now, if controller wants to create some pod on this worker node, controller will tell this kubelet. Kubelet will download the image. Kubelet will create the pod. Okay. So Kubernetes only manages the pod at lowest. It does not directly manage the container. Clear? And a pod is group of one and more than one container. Okay. The network and storage namespace. Clear? Means if there are two containers inside a pod, they can communicate over the local host. They can share the storage like the way your operating system does. Okay. If I'm installing two applications in my operating system directly, they can communicate over the local host. Why? Because they have single NIC card. So pod is also having a single NIC card, and whatever containers are present inside the pod, they will be able to communicate over the local host because they are using the same network resource. They are using the same storage. Clear? And Kubernetes only manage the pod at lowest. It does not directly manage the containers. Clear? Now, the customer will always connect to worker nodes. They do not communicate to master nodes because application pods does not run on master, because master is for centralized management. Though you can treat your master node as worker node, okay, in case you have less number of so you can treat like your master node as a worker node in case you do not have or you have a less number of nodes, but generally the customer will always connect to worker node because they do not communicate to master node, because application pod does not run on master. Application pods always run on worker nodes. Okay, so this will be my one pod. Okay, this will be my one pod. In a single pod you have multiple containers, 1 2 1 2, or maybe let's say you are only having one container. Okay, so this is what a container, this is what a pod. Clear? And this pod actually have the IP address. Your container does not have IP address. If any request is coming on some port number on the pod IP address, with the help of port forwarding, it goes to container. Same as your host machine. So pod is something like treated as a host machine, okay, or a host operating system. So now guys, do you have any questions on this structure? Hello.
Yes, I am here. So my connection problem is my side. My credential, my login has been disconnecting after 5 minutes frequently. So I will go through recording tonight. And if query, then let you know tomorrow.
Okay, Manish. Ashish and Nagi, any issues over here?
No question.
All clear?
Yes.
Yeah. So this is the architecture. Now the
Kaushal, go to that pane, go to the print site. So you have confirmed, you are telling that in the master node, these are below are the 4 services are running on the master node, right? API service controller and scheduler and the etcd. Basically etcd is for the database of the all the containers, right?
yes.
So okay, and there is some services called router, and these things is not running on this Kubernetes.
No, we actually need to configure them separately.
Okay.
By default, your ingress controller does not come with Kubernetes. You have to configure it by yourself. Okay. By default, only these components are available.
Okay, in the community edition, or we can as a open source Kubernetes, these are the 4 are the default one, right?
Yeah.
Okay.
Or
So
Kushal,
what can you
can we install the router in master node, or
tell me?
we need
I heard about
separate?
this.
No, router is a different concept, guys. Okay. What do you mean by a router?
Sorry, software defined network.
Software defined network actually runs on all the nodes, which is, let's say you are running or a SDN pod. SDN pod will run on 3 worker nodes. Clear? Which will maintain the SDN. Clear? Got it?
Got it. As well as we can create the multiple master nodes.
Yes, you can have multiple master nodes. Okay. Because
So
see,
we are
all the
using
communication is done by this API server. So this API server must be having a lot of requests. So you can have multiple API server. You can configure your different etcd. Okay. Other than this master node, that is also option. Clear?
Kushal, we are using any HA based software or the Kubernetes have the functionality for HA inbuilt?
No, for pod HA, you have the controller, no? If this node will go down, controller will automatically create one more pod on this worker node automatically. Clear? So it is a HA for the pod.
No, I am asking for the master node.
For master node, you are not maintaining any HA over here because it is a single master node, no? But if you want
But
to configure two master
we
node,
want,
then you can.
okay, so we are using the inbuilt HA software or we need to install separate HA?
No, you have to configure the things actually. Generally, if you want to, like you are saying about that, I have a load balancer and these are my 3 worker nodes. Okay, all the traffic is coming on it and it is distributing the traffic. Now, if my this load balancer will go down, then what will happen? So obviously what I will do, I
Correct.
will create 2 load balancer and I will place them. Okay, I will configure a floating IP. Clear? And I will like configure a piercing between 2 of them. Okay. Or the synchronization. For that you have the pacemaker. So this is how you can do it in the master node also. Okay. So for multi-master architecture, you can install Kubernetes. Okay, in that way also.
Okay.
Any more questions?
Sorry, yes, Kaushal, so can you please explain this cryo? I've heard about this cryo based discussion. Can you please explain that? What is that?
Cryo is also the same container engine. Okay.
Okay.
Yeah. Actually, the Docker, why Kubernetes is replacing Docker? Because Docker is not that much secure. Because
Okay.
Docker is daemon with, means if you will stop the service, you will not able to build images, you will not be able to like download images, you will not be able to run containers, right? So all the things actually depending upon only Docker. Okay. And Docker is not that much secure. Okay? Because Docker runs always the container with the root user. Clear?
Okay. And one thing, one more, you are writing that SDN pods. Can you explain this? I'm not able to understand this part.
SDN is a software defined networking. See, if you want to connect 3 different machines, or let's say you want to connect 15 worker nodes, how will you do it in the on-premise? Obvious, you need to configure some switch or router, right?
Right. Absolutely.
Now, I cannot configure the switches and router here, okay? Because let's say this worker node is on the AWS, this worker node is on the GCP, but still I want to use them. So what I will do actually, I will actually configure the SDN between all of them. Clear?
Okay.
So SDN is something like a programmatic approach, okay, to maintain the networking, to manage the networking, okay?
Well, fabric solution, which we will be configured on the every worker node. Is it?
Yes, on the worker, on the nodes actually, on the master, on the worker, on the worker.
Correct. So they are communicating. The example you are saying that master node is on GCP and worker node is on AWS. I'm not able to get these lines.
No, these worker nodes can be on different platforms. Now, maybe this is a server, this is also a server. These two are on the different like streams. How will you configure the actually router between them? You cannot. So we actually have a good approach which is called SDN, software defined networking. Clear? So they all have the public IPs. So we can configure SDN between all of them.
I mean, sorry, Kaushal, I'm again asking question. What do you say that if these both worker node on which different? I'm not get that word.
Tell me if this worker node is on AWS and this is on GCP, how will you configure the networking between both of them? Can you attach a switch or router between both of them?
First, my question
No.
is that is it possible? Can put the two different node on the different service provider, and my master node is on the different service provider. Is it possible? I'm not. That is first my question.
Yeah, this can be on Azure. No issues.
So you need the public router connectivity or public IP connectivity for the each worker node, right?
Yes, you obviously you will needing public IP actually. If these are all on AWS, you can set up, or you know that all the worker nodes and the master node, if they are on AWS, you can connect them with in a single VPC. Obviously, they will be able to communicate with the private network. But if they are on the different network also, you can configure SDN. Clear?
Right. That is fine. That is fine. So but this SDN, okay. So let's suppose in my private environment, so I need to set up a full cluster of the Kubernetes, right? So I have my requirement is to install 50 physical server, bare metal server, right? So on the top of that, I will run my Kubernetes cluster, right? So that each rack I will able to install 10 server in each rack. So I have go with the 5 rack solution. So I need to communicate with the each server. I need to opt the SDN solution for that, right? That is understandable. To communicate with each other, I have to assign some IPs to the particular node so that they are communicating each other through some IP, right? That
Yes.
I understand.
Yes.
That I understand. But
see, your worker nodes will get IP, but who will get or who will give the IPs to pod?
Who will give IP to the port? That is the master node, na?
No. Actually, see, if we talk about the container, then Docker provides the IP, right?
Okay, correct. That the
What
Docker,
I
right?
want,
Right.
these three are different physical machines. I want all the pods which are running on these three worker nodes to be in the flat pod network. Means I want to make these pods in the same network. How will I achieve it?
Not get that last question. Sorry, question come again. So
I want
if you
my
want, you can say.
pods. I want to define a flat pod network. Okay, on all the worker nodes. I want to give this range. I want that this pod also gets IP from this range. This pod, which is on different physical machine, also gets IP from this network range. How can I achieve this?
But I think in Docker as well, we will configure this flat subnet in the Docker configuration, right? So
You
we have
cannot.
seen.
You cannot. You cannot connect two containers which are running on two different hosts with their IP address in Docker.
Yes,
That is not
I
possible.
remember. Yes. You said that we cannot run the same subnet on the two different hosts. Yes, I remember.
If you want to define a flat pod network between all the physical machines and all the pods, how will you achieve this without switches and routers?
Okay.
So for that, we are using a programmatic approach, which is called SDN. And one SDN pod actually runs. In this SDN, actually the types of software defined networking tools runs actually. Like Weave you have, Flannel you have, okay, Multus you have, Open vSwitch you have. These are the tools actually, which gives you the privileges to define software defined networking. Clear?
Yes, clear.
So SDN will provide you a flat pod network between all the pods on all the worker nodes. Clear? So you can connect this pod to this pod directly. You do not need to configure any router and switch. Clear?
Okay.
So that is a programmatic approach. Clear? Which actually runs inside the Kubernetes.
But like we are like in OpenStack cluster, we are deploying the external SDN solution, right? Like for the Nokia or for the Juniper or Cisco ACI. So there is nothing involvement in the basically in a worker node. We can say that at a compute level, there is no involvement with SDN. So this is a difference in Kubernetes. There is some SDN thing is coming in by default inbuilt in the Kubernetes or
You have to
OpenShift, right?
configure it by yourself while installing Kubernetes.
Okay.
Okay, you can select. You want to use Weave, Flannel, Cilium, Multas, Open vSwitch, whatever you want to use, you can configure.
Understand. Okay. I think that as the class progress or OpenShift start, so we can get more understanding on that.
Yeah. Okay, we will do it. Okay.
I'm thinking about from the production perspective. That's why I have asking this stupid question.
I will tell you the installation of Kubernetes. You will understand everything. Okay.
Okay, fine.
Yeah.
Fine.
If you want to take a screenshot of this, guys, you can. Okay.
No, I think we will. Okay, we will got the recording and we will get that. Not an issue, I think. Because
Yeah.
Yes.
Because now I'm closing the class actually. Okay.
Oh. Okay.
Today we'll only discuss this architecture part. Okay. I have
No,
another class
that's
on 8:30.
okay.
Okay.
Fine.
Okay.
So is that tomorrow agenda? Kaushal? So
Tomorrow 7 to 8:30 we will
any
do.
7 to 8. No, what is the tomorrow agenda? What is the topic
We are going
tomorrow?
to discuss about pod.
Oh, okay.
Okay.
Fine.
Okay.
Fine, Kaushal. Thank you.
Thank you.
Okay, guys. Yeah.
Bye.